Okay, seems we are live on Instagram and Twitch. So, welcome back everyone to our Codevember session. This is Codevember number 17, no, 27. We will have four Codevember left, including this one. So, today, tomorrow, Sunday, and Monday. So yeah, I think I've handled pretty well this November this year. Um, so I'm starting a little bit late because I was at work earlier today and I needed some time to refresh first and to eat. So I'm starting with 1 hour late, but I think it would not be a problem, especially with the idea I had tonight. Yesterday we made this little guy here, so it's basically a mix with various behavior, but the main idea was at first try to use the Codevember session number 26, where we try to add some separation in our attractive behavior with the little terror in order to simulate the ways simulate the ways I can collide between themselves, and we use a separation function for that. And yesterday we wanted to push this a little further by adding two behavior, which is the alignment and the cohesion, which can give us this little flocking system. It's not perfect, but it's kind of works. So basically the flocking is three behavior, as you might remember. It's described by Craig Reynolds in the earlier 80 in 1986, so 1 year before I was born. And basically you take a Boyd is an entity, an agent, an autonomous agent, and the Boyd can have three behavior: a separation, a cohesion, and an alignment behavior. So basically the alignment says the Boyd will look into the nearest neighbor within a certain range, and he will try to align himself to the average direction of his neighbor. So this is the alignment. It's basically plays on the velocity. Then we have the cohesion. The cohesion is another behavior saying that the Boyd is looking for the nearest behavior, again in a certain range, and they will try to stick to the average position of the neighbors. And we have the separation, which says that the Boyd is looking for the nearest neighbor, and he try to stay at a certain distance with them. So it works with the cohesion because we want to go near the neighbor but not too near. So this is how we get this little behavior when we can have 3, 2, and 4 Boyds together flowing in the same direction. We also add a little bit of a curl noise to disturb all this behavior, some kind of a little wind, and why we wanted to, at first I wanted to work with some little diamond or pyramid, and while we were working with that yesterday, I had decided to play with paper plane, and I thought it might be interesting to have some kind of man made of paper plane, and the plane are going from their place on the vertices and flux. So basically the system is composed of simple things. So we have two layers for that. The first layer is a same layer we use on a previous experiment. It's this second layer of behavior using the compute shader we've made on the session number 24. So we have some static paper plane on the body. So this is the static paper plane on the body in order to draw the body, because we want to draw the body, of course. Then we have the second layer, which is this one. We have 1,000 of Boyd which can flow behind us. So we have also some edge. So when the boards are going beyond the world, they basically respawn to the original position they got at first. So they're going from the body to the world. So this simulate the way that we can have some little elements going from the body and flowing. So I want to explore a little bit further this behavior, and I don't want to work with flocking. I basically want to work with curl noise, because I had this idea while we were working on that yesterday. I set up a little tweak when we try to understand the physics. We only use the curl noise, and it was quite interesting to have this curl basically flowing all over the place. And I was thinking about having a lot of particles going on curl noise, and we could modulate a little bit the curl noise by using the noise in order to use the multiplier of the curl noise. I will explain that later. And in order to draw the body, I was thinking about, we have this little box which is our rod. So the curl noise, when a curl go out, it can also respond from the original vertices. So that's okay. So that's the main behavior. But it can be interesting to compute the distance between each particles to the nearest vertex on the body, and depending on this distance, we could also change the size of the particle and change the glow of the particle. So it can be a way to draw with light the body. I'm not sure if I'm explaining well, but I think it could be really interesting. So let's try to do that. It's 22, so I think we could be able to make this in 2 hours. It's really a simple idea, but we will need to think a little bit about it. So first of all, as the usual, I will save my scene as a new iteration of this one, so it will be 27. So 11:27, this is the scene of today, and as usual I would need to duplicate every elements, so the compute, etc. So let me just duplicate the material. The compute is okay. In the shader I would need to duplicate the instance shader, so we would intervene in the surface shader in order to make the glow. Let's wait until it's duplicated. Duplicating an instance surface shader might be a little bit long. Ouch. My thumb just cracked. Okay, duplicating the controller now. And the GPU mesh controller. And again, we will reopen everything and modify to have the proper behavior. Okay. That's okay for this one. Let's take the GPU mesh controller, not the meta, but this one. Let's open the shader row. The compute one. Okay. So this is 27, and this one we will work with that. Okay. I think we will work with spherical particle. Might be a good solution. Or if we want with smaller one, we could play with cubic, but I think spherical is really interesting. Okay, so let's remove this little guy here. Let's use the GPU mesh controller 27. Let's start with 2000. As we will use the same compute shader as yesterday, let's start with 1 in order to don't have a loss in performances, because as you know, as we told yesterday, when we try to use the flock, we have our flocking system is not the best optimized one, because in all function we loop through all the other instances, which is clearly not optimized, but it was a way to prove the concept. So of course we would need to rework on that. So yeah, I was wanted to play with the sphere. As I remember, I need to get a smaller sphere. So let's get to minus to 0.1 to 0.2. Oh, my bad. Okay, so let's create a model description, which is here. And that is okay. And let's go to this 1127. So that's the same. I want the 1127 as a compute one. We will use the same ramp. So let's use this one. Remove. Okay. Oh, and I need to change a little bit this part in order to say that we are using in the custom one the 27. So if everything is working, let me change the camera in order to get the proper one. It's okay. So now we could see a flocking of particles. Okay. So yeah, that's the main idea, but without any flocking behavior. So let's go back in our compute shader and let's get rid of every little guy here. I don't think we would need the cohesion, the align, and the separation, because I think I would only need to try the let's keep the seek for the moment, but I think I don't need the seek also. You know what? If I want the particle to something like, okay, no, let's get rid of the seek. I think I will not need that. The size is okay, so I don't need this, the aligned equation, so I will only keep the curl. Okay. Position, curl in, the time, the curl speed. This one we'll use it later. That's what I need. So let me just go back here. So the min max speed is needed, of course, because we are using and let's try to use this using a min force and the same thing as here. So okay, we use a linear interpolation in order to get a random force, a random speed, in fact, for each particle based on a random value based on their size. Okay, so that could be okay. This is not necessary. This is okay. This is the way we are computing the edge, so this could be correct. Okay, so now it's only a curl, so that's okay. we need to change really the size. So let's put some minimal size, and then we'll try to find a maximal size. 001 might be a good minimal size, so let's try to find now a big one. Okay. So each time we are going here, so that's not a problem. And now we can try to add more. That's what I thought. With too much elements, it's kind of complicated. Let's try with a simpler shape. Yeah, of course. Simpler shape is better because less elements. So that's the main idea. So time to work on the main system. So what we want is basically change the scale based on the distance from the from the vertex. So what does it mean? It means that basically we are looping on all over the distance, and we try to find the minimum distance to the vertex, and then we will try to use this distance. So let's try to do that here. So for int I equals 0 and I is less than position count, and I plus plus flow 3 vertex is basically equal to position, this is this buffer at index I, and now I will need to get the distance between our position and the vertex. So this is basically this. We take the distance between this and this. Okay, and now let's think about it. So I want to get the minimal distance, and if this, and then the distance I want to, I think this would be the better way. Let me, oops, my cable in my headphone. Okay, so yeah, the main idea would be to have something like that, computing the distance between the vertex and the instance. I want to keep only the minimal distance. So if so I need to put a ratio. I need to save this distance, and then after that I think I would need to normalize this distance in order to check normalizing the distance could be interesting, but yeah, I think this is good. And the things, this is the hypotenuse, so I know the main distance. Okay, so let's try the first part. The first part would be getting the minimal distance. So let's write something here which is basically the min dist. And at first we would say that the min dist is basically a really high value. This is my idea. So let's say something like 100,000. Okay, and basically if our distance is less than min dist, yes, let's say less than min dist, then we will swap the value. So we will say that min dist is equal to the dist. So by saying that, I would end up here with the minimal distance. So now I need to normalize this value. For that, I need to know the maximum distance between an element and what's this between the vertex. So I could take the box and try to get the hypotenuse which go from the bottom to a top in a diagonal, in fact, you know, but I'm not sure this is the best way to do that quickly. I would need to compute two hypotenuse. I could do that in the GPU mesh controller, but I'm not sure about that. I'm quite sure about the fact that it would work, but it would give me a big distance. But those my vertex is really in fact, it could be the maximum distance. Or two things, in fact. I'm just thinking on another solution. So here I'm getting the minimum distance. But instead of getting the minimum distance, I could get the difference between the two sign distance fields. That could be really interesting. That would be better. It would get me a proper value, I think. Let me try that. Float 3, and we'll call this the nearest. And let's say that the nearest is basically at start the float 0. And if we form this, and the nearest will be basically equal to the vertex. So I could now try something like that. And of course, let's displace everything directly here. So now I could basically compute the sign distance field of that. It would be really interesting. So I could have something like I'm trying to understand the thing I have in mind. Let me just grab my notebook. Okay. So let's say this is my vertex and this is my other value and this is the center of my box. So I would have a sign distance field of this is 0, maybe something like 0.25, and let's say this is 0.5. This could be that. Yeah, let's try that. Okay. So this is the FDF instance box. So this is the sign distance field from the instance to the box. This is the center box. And we will compute the sign distance field to the nearest element, SDF nearest box, which is basically nearest minus centerboard, so this is the same. And I could have something like float let's call this ink size for the moment, which could be something that so the ink size would be something like taking the nearest SDF box minus the instance. So this could give me something like, if they're the same, it would be 0. If it is bigger, it would be, and also I need to get the absolute value, because if my instance is inside the body to the nearest, that would be something like minus something. So okay, and if I say 1 minus, I will invert this, so if the element is on the vertex, it would be 1. Let's check something like that. If statement conditional, oh, it's a float 3, yeah. I mean, this is clearly a float. And declare identifier SD box, of course. Let's rename that in the proper way. Yes, I haven't renamed this. Okay, let's try that. So the problem is the size is clearly not the same for everyone. So let's try to set the same size for every element. It seems to be working. We kind to distinguish a little bit of a shape inside of it. Let's try to increase the number of elements. I think we could distinguish a little bit of a shape inside of it. So of course, as we can see, because the trying to think in the same thing. Okay, so yeah, I think we will need to change this a little bit. So we will need to remap the size. Okay, but we can see that the size is basically going up and down, up and down, up and down, because the foot are moving. So some vertices are approaching, then go back, then approaching, then go back. So I think we could basically do the same things that we've made the last time by saying something like that, using a simple smooth step, but instead of doing for this, we will be using on this. So we would have something like going from 0 to 25. And now we will invert that, and we could simply change the size by saying that it's basically a lap between I know that I'm clearly redefining the size here, but let's try that. So we go from this to the max scale, multiply by the model description, which is here. We've put that. So that could do the trick. And for the offset of the linear interpolation, we will use our new ink size value. So now, as you could see, I have basically the same size for everyone. So that's correct because I fed it. I want it to have the same size, so let me reduce a little bit. So the main size is 001. And now we can a little bit distinguish the body directly inside. It's not perfect, as I said, but it's kind of doing the trick. We would need to change the size although, but let's try that. We distinguish a little bit the body. The performance are still interesting. Okay, let's put this little value here directly also on a data, let's say the data W, which is not used, so we could use that in the surface shader. So let's retrieve that. Float glow would be glow, which could be simply in.data.w, and we could say something like o.emission plus equal glow. So I could have some new glow directly into this little shape. As you could see, it doesn't seem perfect, but let's try to change that. Let's deactivate, no, let's not deactivate this one. Let's try to change this in the compute one, and let's try to set the proper value, in fact, because I haven't set the proper value. It was the ink size I wanted to put and not the instance box, because the instance box is basically the distance to the box. So now we kind of distinguish the body directly into this. So maybe the value is really too big for the smooth step. So 25 is a little bit too much. So that is more interesting now. We have a little guy here. Let's reduce again. Looks like we have a little bit of a How we change? Oh yeah. my, I always changing the same value but not the one I wanted, so that was the one I wanted, so something like that. I want to work on the ink size and not on the SDF box. Yeah. Now we can distinguish more the body directly into the shape. So, something new also might be to tweak a little bit the time. So, here we have the curl. We let the curl flow. It's not a problem, but we haven't set any time value for any element. So let me get one. So we have everything like that. So remember, we had something like that. So I will take this and try to put here. Okay. So let's try to check. I think is animated is never used. Random per loop, I don't think it's used also, but yeah, it's never used. The loop is used and this is used, so let's try that. So this would be oppose, and let's get rid of this part. So yeah, random, this is random per instances, which is basically, in fact, this value go from 2 to 4. This max time floor, I don't need a here's time for the moment. We have a loop, we have the A loop. If it's different, the same, okay, it's a difference, we will reset everything. And if it's this, if we are on the new loop, we will reset the position, which is here. So my way here, my idea here is to try to add some time to our instance in order them to let's say true, and let's try with a fixed time. So if I put some time, my instance will flow, and even without reaching the edge of the world, they will kind of respond directly on the body, and in this way we kind of less flow outside the body and more elements spawning directly on the body. And because of the glow, we will have more elements on the body. So now, as you could see, we respawn every 2 seconds, and every 2 seconds we can see the body, which is reuniform. So if we basically offset a little bit everything, we could add and now we kind of distinguish the man. We still have the particles though, but we can distinguish a little bit our guy directly into it. So of course now we would need to change this a little bit and try to use different kind of shapes. That's how it's a diamond. So now with the diamond is really more interesting because we can see everything. You could also try to not reduce the size, but only play with the glow. But yeah, as you could see, we only distinguish a little bit of the shape, so maybe something like 0.25. Okay, 0.1. Okay, 0.5. Of course, we will need to add more color into it, but we can start distinguish a little bit the guy when you're walking inside of it. Okay. I think 10,000 is enough. Okay. I also said that it might be interesting to play adding some noise directly into this. So let me just change that to that. Okay. So yeah, I said it might be interesting to add a little bit to noise directly into that. So let's try that. So let's add a noise to to that, plus basically the time in order to get a proper value. Multiply by 25. So now we have some kind of a noise, and we could say something like, we could go from 0 to 4, so it could tweak a little bit the curve. But as it's take the position and a lot of randomness into it, I think I would try with a noise based basically on the time. Not sure, but yeah, it would work. Okay, so now that we have that, we could add more behavior to that in order to orient everything. So let's try, for example, to add something like a wind or an anti-gravity system, so something like that. clearly 0, 1, 0 might be not the correct value, as I think it would be too big, so everything could be disappeared. But yeah, that's what I thought. We don't want to override the noise. Clearly not sure about this value, but a wind based on the direction, why not? 0, 1. Okay, yeah, something like that could be better. And now we could distinguish a little bit more the body. Okay, I think we have all the particle I wanted. Try to think about that, but I think this could be better. We could add a little bit more particular, but I think you would have the same ideas as yesterday. So, simply taking another compute shader to fix the behavior. So it might be a solution. But let's try to just finish that. Okay. So if we want to go back here, we would need to add a little bit of more value here. Let's say we would use a glow emission, and this value will basically help me to manage the power of the glow. So that could be multiplied by that. So I've used a saturate of a ramp, and I've used the ramp. Okay, so we already have a ramp. So we could use the same thing as we always do here, by basically taking the ramp and putting some color into it. So let's try that. Okay. Do we have a ramp? We have this one, and I think we would need to add a more powerful ramp like this one. Put a little bit of an emission directly into this. Don't want to disturb too much the color, but might be interesting. is metallic, the roughness, the metalness, which might be too much, I think. Something like that could be quite beautiful, powerful, colorful, etc. So okay. Also need to remember that yesterday we changed a little bit the profile of the post effects as we changed the bloom ratio. So now the bloom is a little bit more powerful now. Okay. And maybe a double ramp. We've used some of them here. Remember, we've tried some double ramp, for example this one or this one, but I really like these two ramps and I think they could work pretty well together, so maybe it might be interesting to change this. I'll try to change this to ramp. Okay. So for the ramp we have this albedo. That's okay, but I need to have another random value per instance. Or instead I could use a noise. I could show the noise. Yeah, I could choose the noise. In fact, could show with computed noise here. So that's okay. So we could basically put the noise call in our data.y and try that. So this would be in dot data.y. I'm in caps lock, so in dot data.y, and we will use in dot output. So as the y value, we also need to change our little not the photo. You just seen a photo of my food because I'm trying to work on a project where I need to scan the food to compute the size. So that's why you've seen some scan of my beautiful socks. Okay. So I said that I wanted to use these two, so let's get them. Oh, that's the first one, and I thought it would be interesting to use the second one, which is this one. So let's use a simple mask for that. Let's say 26. Okay. So when we click play, I thought some things that I wanted didn't was proud enough, which is the change of color. So of course it's working now, but we kind of have the same color. We used true color, of course, but we're on the same color on the x-axis. Because if I say something like that, for example, so 0.25 instead of our little guy here, okay, we would see that we would have the same color based on the noise, of course, for each particle. And I thought it's kind of disturbing. It's too flat, too not enough interesting. So I would like to add in the x-axis a little bit of randomness, and for that we could say float R&D, and we will base basically this on our little value here, but we will remap this from 0,1 to -1,1 just to have a little bit of an offset. And let's say we want to offset this by 0.25, and we would add that to our x value. So now we will have some kind of a little offset on the noise based on the ramp. That could be more interesting. Yes, this is clearly more interesting. I'm still not sure about the glows out right now, but because I think this glow emission is a little bit too flat, it's not as enough color, so maybe I would basically use that here. So the main idea is to basically set a glow based on the color of the instance. So I could simply try to scale that down, scale that directly, and it could be more interesting now. Because this is too much glow. But that's better. Okay. I think we have it. I'm not sure it's necessary to retake more than that. It was a simple idea I had in mind, so I thought we're at the end of it. we could refine a little bit everything in order to maybe on the compute shader add a little bit of the curve directly in the ink size to be sure. So now I'm going from, let's take that directly here. Oh, no, what? No, it needs to be here. We could basically add an out quad here just to change a little bit the scale. Or we need an or out cubic, for example, to try to avoid some large diffusion on the size. A little bit more interesting, but okay. So that's interesting. We see a little bit of a glitch directly into it, so maybe it's because we have too many elements. Let's say we want so that would be better. And now we could try to add clearly more elements directly into this. A way to do that would be to change a little bit our compute shader to that. So let's duplicate that. Let's say we'll copy the components and paste as new. And I will keep the minimal size, so every element would have the same size. I will need, of course, to update the material. So let's say it's 27.2. Okay. Now what I want to do with the second one is making the same thing that we made yesterday for the paper man. In order to get a man which seems to have a lot of particle into it, I think I would have more small particle flowing around the man, but without computing the sign distance field to the vertex, because this is really expensive. So I could have maybe 50,000 elements, and for that I will simply need to take a copy of the compute shader 27.1. Let's say it will be 27.2, and on the 27.2 I will simply remove the computation on this one. So let's remove the compute for the sign distance field here, so this mean distance, okay, and let's just say that it's basically the mean scale multiplied by that. So we don't need the mean scale, we don't need the nearest box, yes, we don't need that. So I think that's all. Instance box, we have it, so that might be working. Declare ink size here, I forgot something. Oh yeah, in the surface I've used the ink size in data W, which is ink size, we know that's for, yeah, so it would be 0 in this one because this is used for the glow and I don't want these little elements to glow. So let's try that. And as you could see, we now have really more particle directly into it. but we still have a little one which glow on the body. So we could of course try to play a little bit more. For example, if we want something like bigger particles. So I'm not sure, it's kind of interesting, but I'm not sure it's clearly interesting. And you know what, maybe we can, to the edge for each particle, add a little bit of randomness. Let's add a little bit of randomness directly into the for each of one, just to disturb a little bit the edge, because I thought the edge is really too pure on this one. In fact, we could simply, because we have some times directly into it, so maybe we can get rid of the edge, but I think we would lose some interesting values. Not sure, in fact. Getting rid of the edge might be a solution, because the size here, the size is fixed, the size change basically on the distance and that, but we could simply put the normalized time, which is -0 to 1. We could put some inverse of that in the color to change the alpha. So let's try that. Yeah, we have some kind of little edge here. I don't know why, but because I'm working on one shadow only, that's why. So yeah, let me take that. Let's change this by that. Yeah, so now it's clearly just some glowing man. Little bit like fairies. Okay, so let's keep that. So we would not need this instance box here. Let's remove the edge. For that I would need that, but I don't need to remap this one. Okay. And I think that could be the end for this one. So as you could notice, now we have the same effect visually, but we have more it's more subtle now, and it's working pretty well. Well, let's try to reread this one. Something like that might be better. And use an out quad, because I think now the scale is really, we've seen some going from 0 to 1 really quickly. So now it's more subtle. So this is clearly a simple idea, but I thought it could be interesting to try to directly into the particle draw some color into it. Maybe something interesting might be to get rid of the wind in the to compute one, to check if it can, if it can work. So we can little bit distinguish the body directly into it, but it's not that simple now. So maybe a little bit of an orientation, something like that could be interesting, but not, I don't want to put too much wind into it. I'm clearly not sure about the wind. Yeah, something like that. So now we have some elements that are going in front and others that's going behind. I kind of like the way it changed color to yellow, so it's really interesting. So let's try now with various shapes. So we've tried with the diamond. If we go back with the cube, of course the cube are already too big. It'll be something like 0, 0, 0, 0. This is for the cube, but we could add so much different elements. Something like that might be interesting. Too much vertex. We will need to simplify it. Now let's go back to this one. But I think I would try to retake the color on our little particle guy. Okay. Okay, let's go back to the color board now. Something interesting is going from blue to yellow. Ready, let's take a simple gradient here. Okay, we would go to blue. I thought the blue was beautiful to the yellow. Okay, and we pass to a little bit of green directly into it to avoid the gray. So that's was interesting. Okay, that was my main color. The main color I wanted to try with 0. So 27. Okay. And now let's get the two materials, 27 and 27 too, and put the ramp. Too much green into it. I wanted to have more blue directly, so I think I would need to go back to the blue. Yeah, that's more the color I wanted to get. Okay, let's try to add more variation. Okay, so let's try to change that. Maybe something like that could be interesting. Okay, let's put our 22 now. 22, 28, sorry. Yeah, now we have some kind of interesting values. Maybe we can get rid of the alpha test, because it's reducing their shape. So okay. Whoops, made a mistake. Yeah, I think I will stay with this one. I maybe this one might be interesting, but a little bit too colorful. Okay, I think we have it. I think we've done the this one. I'm pretty fond on this one. We could try to increase a little bit the effects by getting some of the value we have on the compute shader, which is we could use the norm time, or we could use the ink size. So the inverse of the ink size might be interesting or not. If I say something like in.data.glow, which is basically the ink size, so .w, I would have a multiplier on the albedo. Not sure about that, because I think the multiplier is no, because now you have something like really without any color into it, so not what I wanted. Kind of interesting, because now we have only colors on the elements, but as you could see, everything turns out gray, so not really beautiful here. No, let's keep that. Let's keep this little guy here. So yeah, I think we have what I wanted to make. It was really a simple idea, this one, and I think everyone using shader graph now with the new universal rendering pipeline from Unity has made this one. It's really as simple. You take a skin mesh renderer, bake it into a texture, and then use it as an emitter for your particle shader. But what I wanted was to try to draw the body directly into the particle using scale and lights. So it's kind of works. It's a little bit foggy, but that's kind of interesting, this effect. And sure, I hope you like it, and see you tomorrow for another Cucumber adventures, and I'll try to find another idea, maybe without exploring physics. I don't really know right now. I will try to sketch something. So I hope you like it, and see you tomorrow, guys. So bye everyone.